All right, our last equilibrium problem here, and I promise you this is going to be as bad as it gets, because what we're going to see here is that a simplifying assumption won't work. We can't use simplifying algebra, and we're going to be forced to use the quadratic equation. So this problem is going to be set up at the beginning exactly like 1710A was. So I'm going to go through that fairly quickly. We write our equation. We write our reaction quotient. We have our concentrations of species, which is COCl2 initially. Where this problem changes is now we only have a little bit of phosgene in that same 10-liter flask. So we've got 0.01 molar. Our ice table is going to be set up pretty much exactly the same, except this is going to be 0.01 here. Kc didn't change. That's the constant for this reaction. So our equilibrium constant is still equal to the same equilibrium expression. And again, I'm just going to circle the points here where it's different from our previous example. So if we go through and we try to make the same assumption, okay, let's say we can write assume x is small, such that 0.01 minus x approximates 0.01. Let's do our check. Okay, our check here means we take our x value, we put it over our initial concentration, 2.9 times 10 to the minus third over 0.01, put that in a percent, and this gets us to 29%. That little bit that we were assuming was going to be small and negligible comprises almost a third of what we were trying to subtract it from. So our assumption fails, fails miserably. So what does this mean we have to do? Well, as I mentioned, this is the worst problem. This means we have to solve it using the quadratic equation. So I'm going to grab another piece of paper here to kind of work through solving this with the quadratic equation. Okay, so what we had here, we had Kc equal to 8.3 times 10 to the minus fourth. It's equal to x squared over 0.01 minus x, right? And so what we're going to have to do is we're going to have to get this all together, combine like terms, and set this equal to 0. So work on your algebra again if this is something that's not coming straight forward to you. 8.3 times 10 to the minus 6th minus 8.3 times 10 to the minus 4th. X is equal to x squared. We need to set this equal to 0. 0 equals x squared plus 8.3 times 10 to the minus 4th x minus 8.3 times 10 to the minus 6th. Again, when you're solving the quadratic equation, the coefficients in front of your x squared, x, and your constant become your a, b, and c values. So my a is going to be equal to 1. B is 8.3 times 10 to the minus 4th. C is minus 8.3 times 10 to the minus 6th. Here's the quadratic equation. Again, will be provided for you. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. X is equal to minus 8.3 times 10 to the minus 4th plus or minus square root of 8.3 times 10 to the minus 4th squared minus 4 times 1 times negative 8.3 times 10 to the minus 6th all over 2 times 1. X is going to be equal to, after we work out all this math, 2.5 times 10 to the minus 3rd and minus 3.3 times 10 to the minus 3rd. Again, one of these answers we will need to reject. We're going to reject this one. It's not meaningful to have a negative concentration. So one of the things that you'll have to think about is looking at the values that you get and finding ways to reject one of the values. Maybe you'll get a value such that, for example, if you got an x value that was greater than 0.01, that would mean we'd have to ignore it because we can't take and subtract that off of this because you can't end up with a negative concentration. So there will be some way that you can reject one of the answers here. So in this case, here's what our answer is going to be. So kind of looking back here, that x is equal to these concentrations, and if we subtract it from 0.01, that will give us our COCl2 concentration. So the concentration of CO at equilibrium is equal to the concentration of Cl2 at equilibrium, and that's equal to 2.5 times 10 to the minus 3rd molar. Concentration of COCl2 at equilibrium is equal to 0.01 minus that x, and so that's equal to 7.5 times 10 to the minus 3rd molar. So that, I promise you, is as hard as it gets, but because we had an assumption that failed, there was no other way to solve this problem other than going through the quadratic equation. Again, I'll tell you, the quadratic equation will always work, but man, it's a pain in the butt to do, and if you can find some way to simplify the problem, simplify your algebra, make a simplifying assumption, then that works really well.